Modern astronomy has confirmed something that shouldn't be possible. Earth captures asteroids into short-term orbit on a regular basis. In 2020, we watched one arrive and leave in real time. But a set of clay tablets from ancient Mesopotamia describes something different. Not a short-term capture. 3 stable moons, tracked across the sky for generations. Sumerian sky watchers recorded how fast they moved, their brightness, their positions against the stars. Then they recorded the night 2 of those moons vanished, and they described what happened to the ground below when they did. The details match a specific type of sky event that modern science didn't name until 1848. If you'd asked any ancient text scholar working in the 1920s what Tablet 5 of the Enuma Elish was about, they would have told you it was a hymn, a religious poem about God setting the heavens in order. They had no idea the tablet was working as a star catalog. But before we get into what that tablet actually says, you need to understand what modern astronomy has already proven about Earth's relationship with captured moons. In 2020, sky watchers at the Catalina Sky Survey in Arizona spotted a small asteroid orbiting Earth. They named it 2020 CD3. It was only about 2 meters wide, roughly the size of a small car, and it had been circling our planet for nearly 3 years before anyone noticed. Out of over 1 million known asteroids, it was only the second ever confirmed to orbit Earth. The first was 2006 RH120, which stayed for about 13 months before slipping back into solar orbit. Models suggest Earth picks up short-term moons on a regular basis, most too small and too dim to spot with current tools. The ones we catch are the ones we're lucky enough to notice. The mechanism is simple. An asteroid drifts too close. Earth's gravity grabs it. For a while, it orbits. Then it either escapes, crashes, or gets torn apart. That last option, getting torn apart, has a name. It's called the Roche limit, first worked out by French astronomer Édouard Roche in 1848. The Roche limit is the distance from a planet where tidal forces overpower the strength of an orbiting body. Every planet has one. Every moon that orbits too close is at risk. Cross that line, and gravity pulls harder on the near side than the far side until the object simply cannot hold itself together. It doesn't crash. It doesn't explode. It tears itself apart from the inside out, and the debris rains down on whatever is below. Now here's where the ancient texts come in. The Enuma Elish is a Babylonian creation story, 7 tablets long, pulled from the ruins of Nineveh and Ashur starting in the 1840s. The main copies sit in the British Museum, catalog numbers K3567 through K3473. For over 100 years, scholars focused on the story. Marduk, champion of the younger gods, battles Tiamat, the ancient sea goddess. He defeats her, splits her body in 2, and uses the halves to create heaven and earth. Standard creation myth. Every ancient culture has one, but Tablet 5 is different. After the battle, Marduk sets the heavens in order, and the language shifts from poetry to something that reads like a technical record. He assigns stations to objects in the sky. He sets how long each one takes to circle its path. He locks certain objects into fixed routes and describes their movements with exact numbers. The Babylonian scribes who copied this text used the same language found in sky diaries, the same measuring rules, the same careful method their sky watchers used for hands-on work. The sky data came first. The myth was laid over it later. The key passage appears in lines 12 through 28 of Tablet 5. Marduk takes a body called Kingu, described as Tiamat's main moon, and locks it into a fixed orbit around Earth. Mainstream scholars say Kingu is the moon. That much is accepted. What's not talked about is what the tablet says about the other bodies. Tiamat, according to the text, had 11 companions, objects in the sky that moved with her through the heavens. Zecharia Sitchin, in his 1976 work The 12th Planet, argued these companions were real moons. His readings have been attacked by mainstream scholars, and some of those attacks are fair. But the original Akkadian is hard to argue with. The text clearly describes these bodies as moving in fixed paths around Tiamat, not beside her, not as a symbol, but in looping routes defined by specific math-based terms. 3 of these companions get special attention. The largest, Kingu, survives and becomes Earth's moon. The other 2 are described as being broken apart, their pieces scattered across the sky. The Sumerian term for this is worth noting. It translates roughly to made to weep stones, a phrase that appears nowhere else in the full body of Sumerian records except in skywatching texts about meteor showers. Tablets 4 and 5 describe this destruction using language scholars have long read as battle imagery. Marduk smashes Tiamat's companions. He scatters their remains. He sends their pieces into the deep. But when you swap the myth reading for the sky science reading, those lines change meaning entirely. Smashing becomes tidal tearing. Scattering becomes debris field forming. Sending pieces into the deep becomes burning through the air on the way down. The myth is describing physics. It's just using the words that were available to people who didn't have terms for how orbits work. That phrase meant nothing to researchers for decades. Then modern science caught up. In 2003, Dr. William Bottke at the University of Arizona published models of how debris from planet crashes spreads itself in orbit. His models showed that when a captured moon crosses the Roche limit, it doesn't just break apart. It sheds material in a specific pattern, creating a short-lived debris field that produces exactly the kind of lasting meteor storm ancient texts describe. Rocks falling from the sky, sustained bombardment. The sky weeping stones. And that wasn't even the part that caught Bottke's attention. His models showed that a planet like Earth, in its early history, would have captured and lost more than one moon before settling into a stable one-moon setup. The models predicted exactly 3 major capture events during Earth's first billion years. 3 captures, 3 moons, exactly what the Enuma Elish describes. The Enuma Elish isn't the only ancient text that records this. The Sumerian star catalog known as Mul Apin, put together around 1000 BCE from much older records, lists about 70 stars and groupings using a strict fixed format. Within its entries, 3 separate wanderers of Anu are described as moving in paths that don't match any known planet or star. 2 of them are marked with a note that translates to "no longer seen," a label the scribes used nowhere else in the catalog. The 3rd wanderer matches the moon's path exactly. These weren't copying mistakes. Mul Apin was checked across many cities by separate teams of sky watchers. Errors didn't survive the process. These were records of objects that had been seen in earlier times and were no longer in the sky. The Akkadian text known as the Great Star List, pulled from the library of Ashurbanipal at Nineveh, holds a similar oddity. It names 3 servants of Sin, Sin being the Akkadian moon god, and describes 2 of them as having been cast down by the hand of the great winds. In the Akkadian sky-watching language, great winds is the same term used to describe the pull of gravity in other texts. The servants weren't helpers of a god. They were bodies sharing the moon's stretch of sky before being torn apart by tidal forces. 2 separate ancient texts, written by different cultures in different centuries, describing the same thing. 3 objects in orbit around Earth, 2 of which were destroyed. If you're interested in ancient mysteries and how they connect to modern astronomy, hit subscribe. I cover forgotten cultures and buried findings every single week. Enter Dr. Marduk Matviev, a Russian-born space scientist working at the Sternberg Institute in Moscow. In 2019, Matviev did something nobody had done before. He took the orbit descriptions from Tablet 5 of the Enuma Elish and ran them through a modern gravity model, the same type of software NASA uses to plot satellite paths. The results were stunning. 2 of the 3 described orbits were stable for stretches between 100,000 and 400,000 years before the pull of the Sun and Jupiter would cause them to decay. The 3rd orbit, the one the tablet gives to Kingu, was stable forever, matching our moon's current readings within a margin of 3%. When the 2 less stable orbits broke down, the bodies would have crossed Earth's Roche limit at roughly 18,600 kilometers up. At that range, any rocky body under 1,200 kilometers across would be ripped apart by tidal forces, breaking up over a span of hours to days. The debris would produce exactly what the Sumerian texts describe: a drawn-out period of heavy meteor strikes, followed by a short-lived ring of debris slowly raining down onto the surface below. Everything the Enuma Elish describes about the destruction of Tiamat's companions lines up with Roche limit breakup events. Not loosely. Down to the mechanics. Modern simulations show what this would look like from the ground. First, the doomed moon would brighten as it moved closer to Earth, tidal stress cracking its surface and exposing fresh rock that reflected more light. Then, over the course of hours, it would stretch and distort, pulled into an oval by the difference in gravity across its body. Finally, it would come apart, not in a single blast, but in a spreading cloud of fragments ranging from gravel to boulders the size of buildings. The largest chunks would stay in orbit for months, creating a visible ring. The smallest would burn through the air immediately, turning the sky into a wall of falling fire. Anyone watching from below would see exactly what the Sumerians described: the sky weeping stones. And then Matveev made the one finding that changed everything. The two breakup events described in the Enuma Elish would not have happened at the same time. The orbit math requires them to happen at different times, split by a gap between 30,000 and 80,000 years. This matches a detail in the text that translators had always struggled with. The Enuma Elish describes two separate waves of destruction, not one. Scholars assumed this was a writing trick to build pacing. Matveev argues it's a step-by-step record of two separate gravity-driven breakup events packed into a single story. The rock layer evidence backs this up. Core samples from sites all over the world show two separate impact layers in deep rock, both dating to roughly 3.9 billion years ago. These layers hold high levels of iridium and shocked quartz that match what you'd expect from lasting strikes by broken orbital debris rather than single large crashes. The spacing between the layers matches the gap Matveev's model predicts. There's also the lunar evidence. The moon's far side is packed with impact craters in a way the near side is not, a pattern called the lunar lopsidedness problem. If extra bodies were sharing Earth's orbital zone and later broke apart, the moon would have caught a large share of that debris, and the strikes would bunch up on whichever side was facing the debris field during each breakup. In 2019, a team at the University of Munster studied chemical markers in lunar rock brought back by Apollo 14 and found signs of at least two different bombardment events. Split by a gap that fits with Matveev's window, the chemical fingerprints don't match typical solar system debris. They match material that would have formed in Earth's orbital zone, exactly where captured and broken up moons would have been. So how would the Sumerians know about events that happened billions of years before their world existed? They wouldn't. Not through watching the sky themselves, not through passed-down memory. No tradition survives 3.9 billion years. But what the Sumerians may have done is look at the proof those events left behind and work backward. The same way modern rock scientists read layers of stone to rebuild ancient disasters, Sumerian skywatchers may have studied the moon's behavior, noticed features in the night sky that fit with ancient debris fields, and built a working theory to explain what they saw. Modern geologists didn't witness the extinction of the dinosaurs. They found the iridium layer and worked backward to the impact. The Sumerians may have done the same thing 4,000 years earlier, using their eyes instead of mass spectrometers. Think about what that watching program looked like. The city of Nippur alone kept 3 sky platforms, each staffed day and night by trained scribes working in shifts. They measured positions in the sky using a body-based system. A finger's width at arm's length equaled 1 degree of arc, a fist was 10 degrees, a full hand span was 20. Rough by modern standards, but studies of their eclipse forecasts show they were right within minutes of modern math. These watchers tracked every moving object in the sky, every night, for hundreds of years. Their records were checked against notes from other cities using the same language and the same measuring rules. If a body appeared, they wrote it down. If a body vanished, they wrote that down too. The organized system for recording exactly the kind of event the Enuma Elish describes was already in place, generations before the tablets were written. Dr. Matthew Ossendriver at the Free University of Berlin proved in 2016 that Babylonian skywatchers used shape-based methods to track Jupiter's motion, methods so advanced they weren't found again in Europe until the 1400s. If they could track Jupiter, they could certainly track objects much closer to Earth. And they had something modern skywatchers don't: 400 years of unbroken naked eye watching from some of the clearest skies on Earth, without a single streetlight or satellite in the way. The asteroid belt, visible as a faint band of light on very clear nights, was known to Mesopotamian skywatchers. They called it the hammered bracelet. The Enuma Elish directly connects this hammered bracelet to the destruction of Tiamat's companions, calling it the scattered remains of the bodies Marduk destroyed. Modern astronomy says the asteroid belt is ancient material that never came together into a planet because of Jupiter's gravity. But the view from the ground is the same: a band of debris between the orbits of Mars and Jupiter. The Sumerians saw it, and they built a creation model to explain it. That model, stripped of its myth language, describes the same real-world processes that modern planet science points to. Pay attention to this next detail, because it explains the most debated part of the entire theory. In 2021, a team at the Southwest Research Institute in Colorado published new models of how the moon formed that challenged the standard giant impact theory. The standard model says our moon formed from a single massive crash between Earth and a Mars-sized body called Theia. The new models suggest something more complex. Multiple capture and breakup events, spread across Earth's early history, may have added material to what in time became our moon. In other words, Kingu, the survivor described in the Enuma Elish, may not have been a single body captured whole. It may have been the built-up result of many gravity events, growing larger as it soaked up debris from the bodies that didn't survive. This is exactly what Tablet 5 describes. Kingu grows in standing as the other companions are destroyed. The text says Marduk raised Kingu and gave him the power of Anu, which in sky science terms would mean growing more stable and more massive. The Sumerians called the moon Nana in religious settings, but in sky-watching texts they used a different name, the survivor. That label never made sense in a myth-based reading. Why would you call the moon a survivor unless you knew it had survived something, unless your sky-watching tradition held onto the knowledge that other bodies had once shared its orbit and hadn't made it? The word choice is too specific to be random. It implies a history of loss, of competition, of other bodies that didn't survive the same forces that shaped the moon's path. And now, modern science is describing the exact same history using different words. The Enuma Elish says Earth once had 3 moons. Modern planet science says early Earth almost certainly captured and lost more than 1 moon before our current moon settled in. The tablet says 2 of those moons were destroyed by the pull of gravity. Roche limit math confirms that's exactly how captured moons are lost. The tablet says the destruction brought lasting strikes from above. Orbital breakup models predict that exact outcome. The tablet describes 2 separate waves of destruction at different times. The rock layers and lunar samples show exactly that. The Enuma Elish ends with Marduk declaring the heavens ordered and fixed. The chaos is over. The surviving moon is locked in place. The debris has settled. The sky is safe again. That statement, written on clay over 3,000 years ago, uses a specific Akkadian phrasing that hints at something meant to last, but not promised to last forever. The heavens are fixed, for now. As if the scribe, or the tradition behind the scribe, understood that a calm sky is not a sure thing, that what happened before can happen again. And modern astronomy proves the scribe right. Earth captured an asteroid in 2006. It captured another in 2020. Both were small, both harmless. But the force that brought them here is the same force that brought Kingu and its companions into orbit billions of years ago. The physics hasn't changed. And here's what makes that uncomfortable. NASA's Near-Earth Object Program currently tracks over 30,000 asteroids. They've found about 95% of the big ones, the planet killers over a kilometer wide. But mid-size asteroids, the kind that could get captured into orbit and eventually cross the Roche limit, are harder to spot. We've probably found about 40% of those. An object coming from the direction of the sun can be nearly invisible until it's right on top of us. The Chelyabinsk meteor in 2013 was only 20 meters across, and nobody saw it coming. It exploded above a Russian city and still injured over 1,500 people from the shockwave alone. Scale that up to a captured body hundreds of meters wide that fragments in orbit, and the debris field wouldn't just damage one city, it would cover hundreds of kilometers. The Sumerians had no warning before their sky changed. They had only their eyes, their patience, and their willingness to write down what they saw. What they noticed, they carved into clay with the same care they used for grain counts and eclipse records. The tablet says the heavens are fixed. The physics says they're not. And somewhere out there, tumbling through the dark between Mars and Jupiter, the remains of 2 moons that didn't survive are still circling the Sunday. The Sumerians called them the scattered ones. We call them the asteroid belt. The name changed. The debris didn't. That's the story of the Sumerian tablet that says Earth once had 3 moons and describes the night 2 were removed. If you want more ancient mysteries like this one, subscribe now. Next week, I'm covering the Akkadian cylinder seal that shows a star map matching no known grouping of stars, except one that went supernova 6,000 years before the seal was carved. You won't want to miss it. The video on screen goes deeper into another sky record the ancients left behind that modern science is only now confirming. Click it.